Hello and welcome to this lecture I put together for you on factorials, permutations, and combinations using Excel. So many students get to things like the fundamental counting principle, and they get to factorials and permutations and combinations, and they freak out, and they really should not, because it's really an easy topic to use your calculator and or Excel on these. In any statistics class, you'll come across factorials, permutations, and combinations. You could use Minitab if you use that in your class. You could use your calculator. For these types of calculations, though, I'm going to show you how to use Excel because it is usually something everyone has on their computer. Now, first of all, factorials. Factorials, you'll see the symbol, it's an exclamation point. It simply means the product of decreasing positive whole numbers. In other words, if I had 4 factorial, it would be 4 times 3 times 2 times 1, which is equal to 24. I'm going to show you how to do these easily, of course. One thing that I want you to remember, students sometimes get confused, but 0 factorial is always equal to 1. So 4 factorial is 4 times 3 times 2 times 1, which is 24. 3 factorial would be 3 times 2 times 1, which is 6. Now, for a little practice, just longhand, think about this. 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. 3 factorial plus 4 factorial. It's like having, you're following your order of operations. So 3 factorial is 3 times 2 times 1, which is 6, plus 4 factorial, which is 4 times 3 times 2 times 1, which is 24. I want to make sure. Yeah, it's 24. So 6 plus 24 is 30. What about 7 minus 3 in parentheses factorial? Well, I would first do the operation inside the parentheses. 7 minus 3 is 4. 4 factorial, 24. What about 7 factorial minus 3 factorial? 7 factorial is a big number. 7 times 6 times 5 times 4 times 3 times 2 times 1 is 5,040 minus 3 factorial, which is 6. 5,040 minus 6 is 5,034. This is just a trick question. 4 factorial divided by 0 factorial. Remember, I told you 0 factorial is always equal to 1. 4 factorial is 24 divided by 1 is 24. What about 5, not 5 factorial, but a plain old 5 times 0 factorial? 0 factorial is 1, so I've got 5 times 1 is equal to 5. You can easily do these in Excel by typing in equals FACT, and I'm going to show you how to do this, not including the quotation marks, of course, and just putting the number there. In other words, pick a blank cell in Excel and type equals FACT 7. It'll give you 7 factorial. Let's pause here for a second. I'm going to go over and bring Excel in. Now here's an Excel sheet that I have pulled up. Let's say, I'm going to type up here just for you to see. I'm going to type a few problems. Let's do 5 factorial. Let's do 7 factorial. Let's do 4 factorial minus 3 factorial. Let's do 6 factorial. Uh-oh, that's not a 6. 6 factorial times, I don't know, 5 factorial. Let's look at how we would do these in Excel. Right under that, I'm going to type the formula equals FACT. Notice Excel guesses what you want to do. So I'm just doing this factorial. FACT, double click, I'm going to put a 5 in parentheses. 5 factorial is 120. What about 7 factorial? Equals FAC. All right, there it is. Double click on that fact. Put a 7 in there. 7 factorial. Bazinga is 5,040. What about 4 factorial minus 3 factorial? This is easy. Equals FAC. Double click on factorial. Put a 4 in there. Close parentheses. Minus FACT. Let's double click. And put a 3 in there. 4 factorial minus 3 factorial. Bazinga is 18. Think about it. 4 factorial is 24. 3 factorial is 6. 24 minus 6 is 18. Excel nails it every time. What about 6 factorial times 5 factorial? Equals FACT. You can double click on that. 6 factorial. Close that parentheses. Now in Excel you use an asterisk for multiplication. 6 factorial. So times 5 factorial. I'm going to double click on factorial. 5 factorial. Close the parentheses. See the formula. Hit the enter key. Bazinga. 86,400. Easy enough. Let's go back to my presentation. So as I noted, it is incredibly easy. I would just type equals FACT. Put a 7 in there. Hit the enter key. Bam. 5,040. What about a big number? Let's say I typed in equals FACT, parentheses 25. Look how big this is. This is 1.55112 times 10 to the 25th. This number is so large that Excel had to use exponential notation. Don't worry about it. Excel nails it. What this number is holy cow. You just take that decimal and move it 25 places to the right. I cannot read that number. It's so huge. But Excel nails these every time. 25 factorial is a very large number. Permutations. Now, after you learn about factorials, you learn about permutations. Permutation requirements. With permutations, there are n different items available. And we're going to select R of them. In other words, it could be 10 and we select 3. You can't select more than you have available. We are considering rearrangements of the same items to be different sequences. In other words, the permutation of ABC is different from CBA and is counted separately. This just means that order matters. With permutations, order matters. All right, the formula. Don't worry so much about the formula because I'm going to tell you how to easily do this in Excel. If the preceding requirements are satisfied, the number of permutations or sequences of our items selected from n available items without replacement is noted by the formula. NPR is equal to n factorial divided by n minus r factorial. So a permutation is a situation where order matters. There are 10 finalists in a local radio station's contest. From the 10 finalists, 3 winners will be selected to win one of 3 prizes. The prizes are $10,000, dinner for 2 at a local restaurant, and a t-shirt from the local radio station. Now, does it matter which one? Does order matter? Would you rather have the $10,000 or the t-shirt? Of course order matters. This would be a permutation. How many ways can you select 3 winners where order matters from 10 finalists? It's a permutation. 10p3, 10 factorial divided by 10 minus 3 factorial. But we can easily use Excel. You know, like with the factorials, we used FACT. With the permutations, we use PERMUT and put in our N, comma, our P. My larger number will always be first. If it's the same number, of course, it doesn't matter. But so I'm going to type in Permut, or P-E-R-M-U-T, and Excel will help you with this. Let me show you what I mean. We had just done these factorials here. Let's come over here and let's do some permutations. I'm going to type permutations. You don't have to type this. I'm just going to give you some examples. Let's do that problem we just did, 10p7. Let's do, I don't know, 8p5. Let's do 12p4. And let's do 7p4. All right, let's do these. To do a permutation, 10, picking 7. I go into the Excel cell, I type equals, start typing P-E-R-M-U. Look, it knows what it wants me to do. Permutation, P-E-R-M-U-T, double click, put in a 10, comma, 7, close that parentheses, bazinga. There are 604,800 ways to pick pick 7 from 10 when order matters. 8p5, let's do this, equals, permutation, double click here, 8, comma, 5, close that parentheses, bazinga, 6,720. 12p4 equals P-E-R-M-U, double click on permut there, 12, comma, 4, boom, 11,880. 7p4 equals P-E-R-M-U-T, open parentheses, 7, comma, 4, close parentheses, boom, 840. I think our problem was actually, I think it was 10p3, wasn't it? So down here below, let's do that one, equals P-E-R-M-U-T. You can either type it or double click on what the function picker wants you to do, 10, comma, 3, close parentheses, boom, 720, just like we said it would be. So you can see how easy it is to use Excel with factorials and permutations. Like I said, if I wanted to do permutation of 10, picking 3, type in P-E-R-M-U-T, 10, comma 3, got to be in parentheses. It will give me 720 after I hit the enter button. Another example, there are 12 students in a classroom and a committee of 4 is to be chosen. The committee has a president, a vice president, a secretary, and a treasurer. 4 distinct positions, so order matters. How many ways can the 4 be selected from the 12 students? It's just a permutation, 12 picking 4. So, did order matter? Yes, there were 4 distinct positions. I could not only be picked, I could have been the president, I could have been the vice president, I could have been the treasurer, I could have been the secretary. So, pick a blank cell, type in P-E-R-M-U-T, or pick it from the function picker after you start typing permutation. It's the first 6 letters, 12, comma 4. There are 11,880 ways. Bazinga. Combinations. Now, with permutations, order matters. With combinations, order doesn't matter. There are n different items available. We select R of the n without replacement. And however, with a combination, ABC is the same as CBA. The best way to explain this to you is with an example. Now, the formula for a combination is different than that of a permutation. It's n factorial divided by n minus r factorial times r factorial. Now, but a combination is where order doesn't matter. Let's go back to our 10 finalists in a local radio stations contest. From the 10 finalists, 3 winners will be selected, and they all win $1,000. In other words, there are not distinct prizes. They all get the same thing. So if you're picked first or third, you still get $1,000. So this is a combination rather than a permutation. Order does not matter. So let's use Excel to do this 10C3. Very similar to permutations, but let's take a look. Now I'm going to type the word combinations here. You do not have to do this. This is just so you can see what I'm doing. Combinations. Let's do 10C3. Let's do 12C7. Let's do 20C5. All right. First one, 10C3. I've got 10 finalists for the radio station, and from those 10 finalists, I'm going to pick 3 winners to all win $1,000 apiece. There are not distinct prizes. Equals C-O-M-B. I'm going to pick C-O-M-B-I-N, double click, 10, comma, 3, close parentheses, boom, 120. 120 different ways to pick 3 from 10 when order doesn't matter. 12 picking 7. Let's say I've got 12 kids in a class and I need 7 to go on a field trip. How many different ways could I pick 7 from 12? In other words, there's no distinct positions. If you're picked, you get to go on the field trip. That's it. Equals C-O-M-B-I-N. I'll pick it right here. 12, comma, 7, close parentheses, 792 ways. 20C5. Let's say I've got 20 kindergartners, and from those 20 kindergartners, I'm going to pick 5 that get to sit at the table with the teacher. All right, there's no distinct positions, okay? They don't get to do anything special other than to sit with a teacher. How many ways can I pick 5 from 20? Equals C-O-M-B-I-N. I'm a double click on C-O-M-B-I-N. 20, comma, 5, close parentheses, bazinga. 15,504 ways to pick 5 from 20 when order doesn't matter. So you can see how easy it is to use Excel. You just type in C-O-M-B-I-N for combinations. I would use the function picker because it will give you the left parentheses. Type in a 10, comma 3 for a combination of 10 picking 3. Let's say there are 12 students in a classroom and a committee of 4 is to be chosen. They're just going to be on a committee. There's no distinct positions. How many ways can 4 be selected from 12? It's just a 12, C4. I type in C-O-M equals C-O-M-B-I-N, 12, comma 4 in parentheses in Excel. And I hit the enter key. I see that my answer is 495. We nailed it. Now, what about those funky questions about how many distinct words or orderings can you make with the letters in the word Colorado or Mississippi? These are distinct permutation problems, and they have a little special formula. The easiest way to explain these is with some examples. What we're doing in these problems where we are dealing with duplication. I'd like to say, think of Scrabble tiles where the letter S, if I've got 2 S's, is identical with a Scrabble tile. So permutations, when we have identical items, there are n items available, and some items are identical to others. We select all of the n items without replacement. We are considering rearrangements of distinct items to be different sequences. Now, the formula for this looks intimidating, but it's really easy when I show you the example. All right, it's n factorial over n sub 1 factorial, n sub 2 factorial, n sub k factorial. Again, the best way is to see an example. Let's say, how many different orderings can be made from the letters in the word book? All right, first of all, how many letters are in the word book? 1, 2, 3, 4. Ask yourself, all right, 4 letters. Then say, all right, how many B's do I have? There's 1 B. How many O's? 2 O's. How many K's? 1 K. So my numerator will be the total number of letters, 4 factorial. My denominator, I'm going to look at the individual letters and see how many times they are duplicated. There's one b, so 1 factorial times 2 o's, 2 factorial, times 1 factorial, or 1, which is 1k. So I end up with 1 times 2 times 1. You say, where's that extra 1? 2 factorial is 2 times 1. So it's really just 24 divided by 2, which is 12. Real easy to do on a calculator or with Excel. If you need to break it down, still easy to do. Let's look at another one. How many different orderings can be made from the letters in the word Mississippi? Ask yourself, how many letters are there in Mississippi? There's 11. Then say, well, how many, duplicates do I have? All right, first of all, in the numerator, 11 total letters, 11 factorial. Then I've got 1 m, so in the denominator, 1 factorial, which is just 1. You could just put a 1, times 4 factorial, times 4 factorial, times 2 factorial. Now, you say, ooh, this is hard. It's not hard. I could easily do this in Excel. In Excel, I could type out equals factorial of 11 divided by factorial of 1 times a factorial of 4 times factorial of 4 times factorial of 2. You have to watch your parentheses, and you need parentheses around the total denominator. I think I need one more parentheses there, to be honest with you. I would check it by hand, and I would do these individually. You usually get 1 or 2 of these problems on a quiz or test related to these. Be able to do it with a calculator, be able to do it with Excel, be able to do it by hand. They're real easy to cancel out. The answer to how many distinct ways could you arrange the letters in Mississippi is 34,650. Now, here's another one, very similar. Sometimes you'll get flags or books. Look at my squares over here. Pretend these are flags on a flagpole. In other words, I have 3 red flags, 2 blue flags, and 4 green flags. How many distinct ways could I arrange those flags? 9 factorial divided by 3 factorial times 2 factorial times 4. Now, why 9? There's 9 total flags. 3 factorial is 3 red flags. 2 factorial is 2 blue flags, and the 4 factorial is 4 green flags. Let me show you how to do this in Excel. Okay, let's look at this problem where we were looking at the number of ways that those flags could be arranged. I'm going to open up a new sheet here in Excel. Remember what we had. We had 9 total flags. I think I had 3 red, 2, I don't know, 2 blue maybe, 4 green, I don't remember. This still works the same for this problem. Let me make this a little larger for you. It might have been 4 blue and 2 green. But in order to see how many different ways we could raise those flags, remember what I said, the formula, I'm going to put this in quotations. This is not doing it in Excel, I'm just showing you. It's 9 factorial divided by 3, I'm going to put this in parentheses, 3 factorial times 2 factorial times 4 factorial. Now, in order to get Excel to do this, I'm just going to come down here, type an equal sign, F-A-C-T, double click on that function picker, factorial, 9 factorial, close that out. There's my 9 factorial divided by. Now in my denominator, I want to put parentheses around that total calculation. So I'm going to put 1 parentheses there. Then I'm going to get my 3 factorial, type F-A-C-T, there we go, double click. There's my 3 factorial. Remember, I'm multiplying that by 2 factorial, so I need an asterisk in there. Times 2 factorial, so I type F-A-C-T, double click here. 2 factorial, close that out. I need another multiplication sign. And then finally 4 factorial. I'm going to close it out with another parentheses. See how I have my denominator? I've got parentheses there to tell Excel, hey, I want the factorial of 9, then I want it divided by this whole product here, 3 factorial times 2 factorial times 4 factorial. Let's hit the enter key and say bazinga when we do, because it's going to nail it. Bazinga, 1,260 ways to arrange those 9 flags on that flagpole. Now, you know, this problem could have been a word with 9 letters, or how many ways can you arrange the following letters? AAA, BB, CC, CC. That would have been 3 A's, 2 B's, 4 C's. How many ways can you arrange 9 books on a bookshelf if you have 3 identical math books, 2 identical religion books, and 4 identical psychology books? Same type of problem. It's all you're doing. So Excel makes these easy. You just say, but what if I'm sitting in a classroom? What on earth do I do? Well, scientific calculators can also easily calculate factorials, permutations, combinations. Let's look at a couple of these. Let's say if you have a different calculator than what I show you here, just Google permutations with a TI whatever model, or permutations with a Casio whatever model. There's a lot of great YouTube videos out there, and I want you to be able to do this. And if you're ever in a classroom with me, I'm always happy to show you how to calculate these with whatever model calculator you have. On this one, this is a Casio calculator I see a lot in the classroom. And this particular model of this Casio, I've got some blow-ups here, like the factorial is actually the shift here on the inverse there of that X value. See the factorial right above that? That simply means I hit the shift key and then hit this button, which is shift factorial. So if I wanted 4 factorial, I'd type 4, shift, and then the factorial. Also, you've got the NPR and the NCR buttons down here, but I have to shift. It looks like the NPR is the shift multiplication button there. So if I wanted to do a permutation, 10 picking 3, I would type in a 10, hit a shift, the NPR button, which is right there, and then hit a 3 and hit enter, and bazinga, it would give it to you. Same way with a combination. If I wanted to do a combination of 5 picking 3, I would type in a 5, hit the shift, NCR button, which is, see it right above the division, 5, shift, NCR, 3, enter, boom, it'll give it to you. Now, you know, just like I said, to find 5 factorial, just enter a 5, hit the shift, and then the factorial button. The answer should be 120. To do a permutation of 7, picking 3, just enter a 7, hit the shift button, the NPR button, then a 3, and hit enter, or equals, whatever your calculator has. The trouble generally is finding it. Once you find it, you understand how easy it is. 7, C3, 7, shift, NCR, 3, hit the enter or equal button, boom, you have it. Here's another one I see often. This is a TI calculator. It's a scientific calculator. Sells for anywhere from $12 to $16. Great little calculator. On this one, though, you'll say, I don't have a factorial. I don't have a permutation button. I don't have a combination button. Yeah, you do. This one's awesome, too. On these, you've got a PRB button that generally, once you hit that button, you'll have a choice between a factorial, an NPR, or an NCR. To do like a 5 factorial, you would enter a 5, hit the PRB button, and then choose. And you choose using your left and right arrows. You'd say, oh, I want to do a factorial. Hit the enter button, and you will nail it every time. I love this calculator. I love the other one that I showed you. They work real well. TI calculators, like if you got a TI-83, TI-84, they work well. Check your manual. So many of you have these nice calculators and you never open that doggone manual. Open it up, learn how to do it. Now, when taking an online test, if you're, take an online class or you're able to use Excel with these calculations, I would use Excel. If it was a test that wasn't timed, I would use Excel and use my calculator too. It gives you an opportunity to learn, gives you an opportunity to do both of those type calculations, either with a calculator or with Excel. When you get in the workplace, you're going to need to be able to use Excel. In the classroom, you need to be familiar with your calculator and how to use it to get factorials, combinations, and permutations. Hopefully this presentation has helped you. As always, I love helping you. I love being able to share this with you. Take care now.